honest with you, this is the hardest case that you're going to see, where you have all three variables and all three equations. You don't have one variable solved for, like we started in the beginning, or you don't have two variables in one equations. Here you have all three equations and all three variables. So the method we're going to take for these ones is just kind of like robotic. You know, you're just going to be like a robot doing the steps, but if you just stick to these steps, you're going to be good every time. So what you're going to do is see which variable to cancel out. You're free to cancel out any variable you want, x, y, or z. Just for yourself, seek out the one that's easiest to do. So for me right now, I could see that these y's already cancel out when I'm adding these two equations. So that's what I'm going to do. So the first step is just to notice which variable you're canceling out, which is y. So just let's just keep that in the back of our mind. So we're going to cancel y from these two equations. This is equation 1, equation 2, and equation 3, right? So we're going to cancel y. So we get x plus y plus z equals -1. Here we have x minus y plus 4z equals -11, and we're adding these. We don't have to do any manipulation. The y's already cancel as it is. So we get 2x, the y's cancel, plus 5z equals -12. Okay, so now I'm going to put a star next to this equation because I only have two variables to work with here. Okay, we're going to come back and work with this equation in the future. But once you cancel out a variable from two equations that contain three variables and you get it down to two, just put a star or something next to it because you're going to be working with that equation in the future. Okay, so now your second step is we chose to cancel y from these two equations. So your next step now is just to cancel y from any other equation, just not these two. So it could be these or these, just not these two again. Any combination you'd like, but it has to be y. So I'm going to choose to cancel y from these two equations here because it's different than the first two that I eliminated it from. So I'm going to cancel y from these two here. So I have x minus y plus 4z is equal to -11, and then I have 4x plus y plus z is equal to 11. I'm going to add these two. Again, notice I don't have to do any manipulations. The y's just cancel as it is. So I get 5x, y's cancel, plus 5z is equal to 0. I'm going to put a star by that equation because I got it down to two variables. Okay, so now with these two star equations, it's just like we've done before. You're just solving two linear equations. So I'm going to put these next to each other now. I'm just going to write this one next to this one. So 2x plus 5z equals -12. So these are the two star equations that we formed. Just putting them there later for reference. Okay, so here it's just like old times. You're going to cancel out any variable you'd like. So it looks like the easiest would be to cancel the z's. So I'm going to multiply a negative to either equation. Doesn't matter which one. So I'll just do this bottom one, multiply by a negative. So doing that, we get -2x minus 5z equals +12. Bringing this down because I didn't do anything to it. 5x plus 5z equals 0. Adding these equations, I get 3x. The z's cancel, and you get 12. 3 goes into 12 4 times. I'm going to divide by 3. So we get that x is equal to 4. That's just one variable that we found, right? But from there, you're pretty much done. If you find one variable, the rest of this journey is going to be fairly simple. So once you get x equals 4, jump back to any of the star equations, sub it in to get the other one out. So x equals 4, you just put it into this, any one. So I'm just going to use this one and put 4 into here. So 5, instead of x, I'm going to write 4 plus 5z equals 0. So give me 20 plus 5z equals 0, subtracting the 20 over. You get that 5z is equal to negative 20, dividing by the 5. You get that z is equal to negative 4. Okay, now once you have two variables solved for, you always jump back to an equation that has three variables in it. So since we have x and z, we're trying to find y now. So I'm just going to refer back to this equation, plug in x is equal to 4 and z equals negative 4, and solve for y. So x is going to be 4, y we don't know what it is, and z was negative 4. That equals negative 1. So 4 minus 4 is 0, so y equals negative 1. So you can put your answer in this notation if you'd like. So x was equal to 4. We just found y to be negative 1 and z is negative 4. So that's how you go about solving these problems. It's a little lengthy, but if you just stay neat and organized, nothing could go wrong. Okay, another system when you have three variables in the three equations. So this is the hardest case that we're going to deal with. So the thing I told you guys to do was just see which of the three variables look the easiest to eliminate. So it looks like these y's here eliminate very quickly when I add these two equations. So personally, for me, I'm just going to go ahead and cancel the y's for these two equations here. So let's see, we have x minus 3y plus 3z is equal to negative 4. And for the second equation, we have 2x plus 3y minus z is equal to 15. When I add these equations, notice that the y's already cancel. So you get 3x plus 2z is equal to 11. Now I'm going to go ahead and put a star by this equation because in the future I'm going to be coming back and working with it. Okay, now the next thing I told you guys to do was, since we eliminated y, we have to stick with that. We have to eliminate y from a different set of equations. So I'm going to choose these two to eliminate y from. So writing these two equations here, we have 2x plus 3y minus z equals 15. Then we have 4x minus 3y minus z equals 19. Adding these two equations, notice that the y's cancel already, so we get 6x minus 2z is equal to 34. And I'm just going to write this equation right next to this one. 6x minus 2z is equal to 34. And I'm going to put a star by it. Because I'm erasing this stuff, but when you guys are writing this stuff down on your paper, it gets very messy. So just put a little logo by the special equations that you're going to work with, because those are the most important ones that we're going to be dealing with. And this 4 kind of looks ugly. Okay, so now it's just back to original elimination, right? With two equations, you could pick any variable you'd like to eliminate. So it looks like the two z's are like just begging to be eliminated right now because there's no manipulation to do with them. If we just added them, they would slice right off. So we have 6x minus 2z is equal to 34, and then we have 3x plus 2z is equal to 11, and if we add these, notice that the z's already cancel off right away, so we get 9x is equal to 45, dividing the 9 over, we get that x is equal to 5. Okay, Once you have solved for one variable, it's game over from there because you could just back substitute your way back to victory. So we got x equals 5. You're going to use one of the start equations now to find the other variable. X equals 5, we could plug that into either of these to get z out. So I'm just going to pick this one. So 3 and x is equal to 5. So I'm going to replace it with that. Plus 2z is equal to 11. So we get 15 plus 2z equals 11. Subtracting 15 on both sides, we get that 2z is equal to negative 4. So dividing by 2, we get that z is equal to negative 2. Now that we have two variables solved for, you want to jump back to an equation that has three variables to find the last variable that we're missing. So you got x equals 5 and z equals negative 2. I would probably plug it into this equation to find y. So let's just go with this equation to find y. So x equals 5. We don't know what y is. Plus 3z is negative 2 equals negative 4. So we get 5 minus 3y minus 6 equals negative 4. The 5 and the negative 6 make a negative 1. Then you're going to add the 1 over. Just cancel. Negative 3y is equal to negative 3. I don't have room, so let me just, x is equal to 5 and z is equal to negative 2. So dividing by negative 3, you get that y is equal to 1. So submitting our answer in this format, we get that our x value was 5, our y value we just got to be 1, and z equals negative 2. And again, you could always plug these values, x, y, and z, into these equations to see if the left side and the right side of the equation agree. But anyways, yeah, these are lengthy, but just stay organized and everything should work out.